Halo semuanya, selamat datang di channel Subindo, channel pengetahuan serta fakta unik dan menarik yang terjadi di seluruh jagat raya. Namun sebelum kita lanjut, jangan lupa tekan tombol subscribe dan nyalakan lonceng notifikasinya, biar kamu gak ketinggalan video-video menarik lainnya dari Subindo.
There is so much out there beyond Earth. You can never truly completely discover the wonders of this amazing universe. Have you ever heard about a parallel universe? Many famous scientists have been giving theories about it, including Stephen Hawking. Until now, it's been a crazy-sounding theory being put forward by researchers looking for a solution to why the universe is suddenly expanding more quickly than it should be. Scientists are therefore eager to know about the Hubble tension and which of these bizarre theories being proposed by astrophysicists can help make the universe make more sense. So, what did scientists actually say about the discovery of a parallel universe? What exactly is a parallel universe? And why is this discovery so shocking for all of us? Let's find out. The idea of a parallel universe sparks some wildish dreams for some of us. The idea of a parallel universe has been around since 1960s, starting from science fiction TV shows and comics, where there were other universes where certain events have different outcomes, where just one crucial decision goes a different way. Perhaps there could be some way to access them. Perhaps particles, fields, or even people could be transported from one universe to another, enabling us to live in a universe that's better in some of the ways than our own universe. These ideas have a foothold not only in science fiction, but in theoretical physics as well. From the infinity of possible outcomes from quantum mechanics to ideas related to the multiverse, it's everywhere. But the most important question is that, do these ideas have anything to do with the observable, measurable reality? Recently, a claim has surfaced asserting that we found evidence for parallel universes from the Antarctic Impulse Transient Antenna, or ANITA. It's true, the experiment found evidence for cosmic ray particles that's quite difficult to explain using only conventional physics. But to leap to the most fantastical, outlandish, revolutionary explanation is absolutely premature. In all fields of science, we have to take tremendous care not to fool ourselves, because we must endeavor to knock down any new, wild hypothesis, and instead make sure that known laws of nature can't conceivably explain what we're seeing. So, when we talk about parallel universes, they first arose in the context of quantum physics, which is notorious for having unpredictable outcomes, even if you know everything possible about how you set up your system. In simple words, if you take a single electron and shoot it through a double slit, you can only know the probabilities of where it will land. You cannot predict exactly where it will show up. To make it even more understandable, one remarkable idea, known as the many worlds interpretation of quantum mechanics, postulates that all the outcomes that can possibly occur actually do happen. But only one outcome can happen in each universe. So it takes an infinite number of parallel universes to account for all the possibilities. But this interpretation is just as valid as any other, and there are no experiments or observations that rule it out. However, while some scientists dismiss this theory as fiction, more proof is coming in about the existence of these alternate universes. Yes, you heard it right. It is not the first time someone has thought of the possibility of the existence of a parallel universe. But recent evidences have led to scientists exploring their options while they try to find a concrete explanation for them. Talking about the discovery that was made in Antarctica, it may feel right out of a sci-fi plot hole, as NASA has detected substantial evidence which could be one of the first ever practically unexplainable events that suggests that the existence of a parallel universe where time moves backwards and the rules of physics are contrary to ours. Wow, doesn't that sound completely opposite of how our universe works? By now, it is very clear that our Earth is a very minute existence in the cosmos, and in spite of all the knowledge humanity has gathered, it is still discovering new revelations every now and then. Sir Isaac Newton rightly said, "What we know is a drop, what we don't know is an ocean." Therefore, the concept of parallel universes is something that looks as if it's right out of the movies or fan fiction, but has certainly aroused the curiosity of viewers and readers everywhere. The idea of existence of parallel universes was first conceived by Princeton University student Hugh Everett III back in 1954. In his theory, he wrote about the possibility of parallel universes, or universes that look exactly like and are related to ours existing, that branch off from our own. This theory, known as Everett's many worlds theory, was one of the most plausible attempts to answer the numerous unanswered questions raised by quantum physics. Everett's approach of this theory contradicted many of the currently accepted laws of physics, and it made many scientists uncomfortable. The thought that the outcome of an event could have been different in another universe at every different time juncture, even having differences as drastic as life and death. Multiverses and parallel worlds are often argued in the context of other major scientific concepts like the Big Bang, string theory, and quantum mechanics. That mysterious process of inflation and the Big Bang have convinced some researchers that multiple universes are possible, or even very likely. According to theoretical physicist Alexander Vilenkin of Tufts University in Massachusetts, inflation didn't end everywhere at the same time. While it ended for everything that we can detect from Earth 13.8 billion years ago, cosmic inflation, in fact, continues in other places. This is called the theory of eternal inflation. And as inflation ends in a particular place, a new bubble universe forms, Vilenkin wrote for Scientific America in 2011. Those bubble universes can't contact each other because they continue to expand indefinitely. If we were to set off for the edge of our bubble universe, where it might butt up against the next bubble universe over, we'd never reach it because the edge is zipping away from us faster than the speed of light, and faster than we could ever travel. But even if we could reach the next bubble, according to the eternal inflation, our familiar universe with its physics, constants, and habitable conditions could be totally different from the hypothetical bubble universe next to our own. This picture of the universe, or multiverse as it is called, explains the long-standing mystery of why the constants of nature appear to be fine-tuned for the emergence of life, Vilenkin wrote. He further added, "The reason is that intelligent observers exist only in those rare bubbles in which, by pure chance, the constants happen to be just right for life to evolve. The rest of the multiverse remains barren, but no one is there to complain about it." So, Vilenkin's explanation implies that in some of the infinite bubble universes outside of our own, there could be other intelligent observers. But in every instant that passes, we get farther away from them, and we will never intersect. On the other hand, some researchers base their ideas of parallel universes on quantum mechanics, the mathematical description of subatomic particles. In quantum mechanics, multiple states of existence for tiny particles are all possible at the same time. A wave function encapsulates all of those possibilities. However, when we actually look, we only ever observe one of the possibilities. According to the Copenhagen interpretation of quantum mechanics, as described by the Stanford Encyclopedia of Philosophy, we observe an outcome when the wave function collapses into a single reality. But the many worlds theory proposes instead that every time one state or outcome is observed, there is another world in which a different quantum outcome becomes reality. With that, we have come to the end of our video. What are your thoughts on today's video? Share with us in the comments section below. If you like the content, do give it a thumbs up and subscribe for more. Until next time, have a great day, and thank you for watching.